Working on the Excalibur card again. I now have a 3000 watt 60 volt. See that here? Boma brushless motor mounted up, and this big old giant speed controller. And I've got, for now, two 12 volt 15 amp hour SLA batteries on this side, and three, count them, 1, 2, 3 12 volt 15 amp hour SLA batteries on this side. They're all wired in series, so we have a 60 volt 12 amp hour battery pack. Got our circuit breaker, kick it on off switch, and the throttle. But it goes backwards, and we're in forward. Let's flip it in reverse. Goes forward, but at a reduced speed. So, checking my old records, before, to switch the direction on one of these little brushless motors, I had to switch around two of the big power wires. That would be these guys right here, and then also in the small hall plug, two of the wires. So according to my notes, blue's got to go to green and green's got to go to blue. So I have to move this blue over to here to line up with green, and I have to move this green over to here to line up with the blue. And then we'll leave yellow to yellow. Then in our hall plug, we got to do blue to yellow and yellow to blue, and then the green stays the same. So the two outer ones right here, blue and yellow, will have to be switched. I just had to use a small screwdriver to pop the little pin over here and slide out our yellow and blue wires. Then I switched them around. So now when we plug it in, you can see we got blue, green, and yellow. Down here we got yellow, green, and blue. So yellow lines up with the blue, green's with green, and then the blue lines up with the yellow. Then the red and black, the other two on the hall plug, you don't mess with. And now we'll switch our power or phase wires. Alrighty. Come off here. Let's switch them over. So now we've got blue to green, and green to blue, and yellow to yellow. So now we just simply put our nuts back on. Let's tighten it down and put our cover on. Alright, that should do it. Now we've got blue to green, yellow to yellow, green to blue, blue to yellow, green to green, yellow to blue. Flip our circuit breaker on off switch. We are in the forward direction. Throttle pedal. Yeah. And now reverse. Yeah, that's what we wanted. Alright, it kicks in hard late like that. Here how it kicks up to like a high RPM, and then it kicks up higher. That's it, full throttle, both just holding full throttle. Well, seems to be working properly. Switch off, circuit breaker off. Make a new cover for that. Get her all back together and go from there. Now I'm working on getting our circuit breaker mounted and everything. Cut up a couple of pieces of Lexan, embedded some nuts or countersunk them. Then I'm going to mount these on each side of our circuit breaker, and then use these to mount it down. Alrighty, I have now installed a precharge circuit. This right here is a 10 watt 1 kilojoule resistor, and we have a switch, and then it crosses from one side of our breaker to the other side of our breaker. This is our power inside, so I got the resistor on the power inside and the switch between the resistor and the contactor, so the switch sees the reduced voltage. But it's also a DC rated switch. Let's see what we got here. I don't know if you can see that, but it's 125 volt DC at 0.03 amps. Or no, 0.6 amps at 125 volts DC, 0.3 amps at 250 volts DC. So going by that, at 60 volts DC, we should get at least 1.2 amps. Alrighty, got a meter set up here. Got our negative terminal hooked onto the negative of the battery. These two batteries are in series, and then these three batteries are also in series. So this would be our positive terminal. And oh, there we go. So our battery pack is showing 64.9 volts. And then let's see here on our, the input side of our contactor, we got our 64.9 volts. So that's right from the battery terminal to the contactor. 64.9. Right now, the contactor is off, and therefore this side of the contactor, we're showing 1.7. So that must be the residual current in the capacitors in the speed controller back here. Alrighty. Let's see if I can get that. Alrighty. And then, just to show how our precharge circuit works, push this button here. Our voltage will be able to jump across to this side and slowly fill up our capacitors while the switch is still off. So it'll just be a reduced amount of voltage. So I can get both in frame here. Switch right here, engaged. And that's only what, maybe 30 seconds? There we go. We're up to the 64 volts. So I can release our precharge. And our caps. Our system's showing 64 volts. Or in the caps anyways. With the switch still off. This way, when the switch gets turned on now, the switch won't see a hard inrush of current across the contacts, but also the caps in our, or the capacitors in our speed controller won't see that huge inrush either, because they've already been filled up slowly with our precharge. Now we can turn our breaker on. The system is energized. Switch on. Now we get almost a 2-volt drop with very little load. Alright, well that demonstrates our precharge circuit here. Get this off of here. Turn our system off. And our breaker velcros down. Right there, good and solid. So when you're sitting in the seat, breaker is right handy at your right hand. Easy breezy. Alrighty. That's all for this one. More to come. Here's a quick little diagram I drew up of our DIY precharge circuit. So this would be our battery pack and the positive terminal, which goes to our circuit breaker. And it comes out of our circuit breaker, feeding our speed controller. Our precharge circuit connects to the battery side of the circuit breaker with a, in this situation, a 10 watt 1 kilojoule resistor, which then goes to a small switch that connects up to the other side of our circuit breaker. So this way, when the circuit breaker is off, there's no power getting across. The battery is separated from the whole rest of the system. But if and when you push this momentary switch, like a push button switch, it connects this like jumper circuit, bypassing the circuit breaker through a resistor, and lets just a small amount of voltage across at a time. So this way we slowly fill up the capacitors in the speed controller. Whereas without a precharge circuit, let's say the system's been down, you haven't used it for a couple of days or something like that. You go to use it, and you turn this breaker on, the capacitors in the speed controller are empty. So they want to suck up and draw a whole bunch of energy quick to fill themselves up. The switch in your circuit breaker is going to see that big giant surge of energy and could potentially damage the contacts in your circuit breaker. But also, the capacitors get that big giant surge of energy, it's called an inrush, and can blow out your capacitors if not the first time, over time. So with a precharge circuit like this, we can, before use, connect our precharge circuit or engage our precharge circuit, slowly fill up the capacitors in the speed controller. It only takes like 30 seconds or so. And then, when we flip the main switch on, the capacitors are already filled up. So basically the battery and the capacitors in the speed controller are at the same level. So that way when we flip the switch on, it's just making a connection. There's no energy, or not a big giant bunch of energy running across, because it's already equalized. Hopefully that explains it a bit. And yeah.